towns A and B are 500 km apart. A train starts at 8 am from A towards B at a speed of 70 km per hour, and 10 am another train starts from B towards A at a speed of 110 km per hour. When will the two trains meet? Again, similar to the previous type of problems, easily you can solve. See here, two towns A and B. So A and B, A and B. So how many kilometers apart? 500 kilometers apart. 500 kilometers apart. 500 kilometers apart. Now, a train starts from A at 8 am at a speed of 70 km per hour. Now, another train starts from B at 10 am at a speed of 110 km per hour. So, when will the two trains meet? Very simple. See here, after 10, two trains will be in the movement. So, after 10, we can go with the relative speed. Both the trains are moving in the opposite directions. So, we can add the speed after 10 am. So, till 10 am from town A, the train is going to travel for the 2 hours alone. So, from 8 o'clock to 10 o'clock am. So, 2 hours it is going to travel. 2 hours it is going to travel. So, 2 hours means the distance will be speed into time, which is equal to 140. So, at 10 am, so it has covered 140. So, what is the remaining distance? That is 360. That is 360. So, this is 70 km per hour. 70 km per hour. So, now both the bodies are in the opposite direction, and both the bodies have the movement. So, now both the bodies are having the movement. So, both the bodies are moving in the opposite direction. We can add their speeds. So, S is equal to S1 plus S2, which is equal to 70 plus 110, 180. So, 180 km per hour. So, 180 km per hour, time, hours is required, distance is in kilometers. So, no conversion is required. 180 is equal to the remaining distance, that is 360 by time. So, time is equal to 360 by 180, which is equal to 2. So, after 2 hours they are going to meet. So, 10 o'clock plus 2 hours, which is equal to 12 noon, which is equal to 12 noon. So, at 12 o'clock in the afternoon they are going to meet each other. Therefore, option B is the right answer. Option B is the right answer. Very simple. At what time both the bodies are be in the movement, that we have to consider. So, till the movement starts of the two bodies, the single train is going to travel. So, how much time it is going to travel? Here in this question, 2 hours it is going to travel. So, for the 2 hours, how much distance it is going to cover? 140 kilometers. So, the remaining 360 kilometers, at that time both the bodies will be in the movement, both are traveling in the opposite direction. So, if both the bodies are in the movement, you can add their speed. So, after simplification, you are going to end up with 2 hours. Means after 2 hours they are meeting. So, 10 o'clock they have started together. So, after 2 hours means 10 plus 2. So, 12 o'clock, that is 12 noon. Okay. So, let us move on to the next problem. Now, boats and streams. Nowadays, the problems from this concept we can see in the clerical level as well as in the PO level exams. So, but the problems will be very, very simple. The complexity of the problem will be very, very less in these problems. Okay. So, now, boats and streams. See here, you have three conditions in this problem. One is the boat is going to travel in a still water at a speed of some kilometer per hour. For example, boat is going to travel at a speed of 50 kilometer per hour in still water. Next, boat is going to travel at a speed of 50 kilometer per hour with or towards the flow of water, Okay. So, this is second condition. Here towards the flow of water means the water is also having some speed. Okay, so the first one is the boat is going to travel in still water, and second case the boat is going to travel along with the water or towards the flow of water, where the boat speed is 50 km per hour and the water speed, let us consider 10 km per hour. Let us consider 10 km per hour. Here the water is going to push the boat to travel towards the flow, where the water is also giving extra speed to the boat, and the boat is having 50 km per hour before itself, and the water is giving 10 km per hour extra speed. Therefore the new speed or the speed of the boat towards the flow is equal to 50 plus 10, which is equal to 60 km per hour, because the water is helping the boat to go towards the flow. Okay, because the boat is going towards the stream or towards the current. Okay, towards the stream or towards the current, where the water is giving extra speed to the boat. Therefore, because of that reason, we have to add the speed of the water to the speed of the boat. Now in the third case, the speed of the boat is 50 km per hour and it is traveling against the stream. So if it is traveling against the stream, then the flow of water is an hurdle. It resists the boat to travel against the stream, means the water is an hurdle for the boat, and obviously the speed of the boat is going to be reduced. So consider the stream is 10 km per hour. Therefore 50 minus 10, that is 40 km per hour. So against the stream, the speed of the boat will be 50 minus 10, that is 40 km per hour. In the first case, still water, where the water is having zero speed or no speed, only the speed of the boat is going to make the impact. In the second case, the water is having some speed and boat is traveling towards the stream or in the direction same as the flow of water. So here the water is going to add or give the speed to the boat, so that the boat is going to travel with extra speed. So initially the boat had 50 km per hour, now the water is giving 10 km per hour speed, so the speed of the boat is going to become 60 km per hour. In the third case, against the stream it is going to travel, where the stream is going to become the hurdle, where the speed of the boat is going to be reduced. If the speed of the stream is 10 km per hour, so if the speed of the boat is 50 km per hour, so against the stream it is traveling, so the speed is going to be reduced. So the ultimate speed will be 50 minus 10, which is equal to 40 km per hour. So one thing you have to remember, if it is going to travel in the still water, then the speed is going to remain same. If the boat is going to travel along with the water or towards the stream or towards the flow of the water, then you have to add the speed. Against the water, you have to subtract the speed. Only these three conditions are there. If you follow these three conditions, then you can solve any variety of the problem in the boats and streams. Okay, let us solve the problems. Problem number 1. When the speed of the boat in still water is 4 km per hour and the rate of stream is 2 km per hour, find the upstream speed of the boat. See here, in upstream, the speed is going to be reduced. The speed of the boat in still water is 4 km per hour. Speed of the stream is 2 km per hour. While going upstream, means against the stream, against the flow of water, there the water is in hurdle. So speed of the water is in hurdle, which reduces the speed of the boat. If the boat is traveling at 4 km per hour and the water is resisting the boat at 2 km per hour, then what you have to do? You have to subtract, then the answer will be 2 km per hour. See here, there is a slight changes between the time and distance concept and boats and streams concept. In time and distance, if both the bodies are moving in the same direction, we have to subtract. If it is in the opposite direction, we have to add. But in the boats and streams, if both the bodies, means water and boat, are traveling in the same direction, we have to add. If both are moving in the opposite direction, we have to subtract. we should not confuse by seeing both the varieties of the problems. Please remember the concept and answer the questions. See here, upstream means against the water, so we have to subtract. So after subtracting, we got 2 km per hour. Option C is the right answer. Okay, let's move on to the next problem, problem number 22. If the speed of the swimmer in still water is 9 km per hour, find the downstream speed of the swimmer when the river is flowing with a speed of 6 km per hour. Downstream means towards the flow of the water. Downstream towards the flow of the water. So towards the flow means we have to add their speed. So 9 km per hour, that is in still water, that is the speed of the boat, plus towards the flow, that is downstream, that is 6 km per hour. If you add both the two, then you are going to end up with 15 km per hour. 15 km per hour. So option A is the right answer. When both are moving in the same direction, we have to add. So 15 km per hour is the right answer. So let's move on to the next problem, problem number 23. A swimmer's speed downstream is 11 km per hour and the speed of the stream is 1.5 km per hour. Find the upstream speed of the swimmer. See, they have not given the speed of the boat in still water or in the current water, but they have given the speed of the boat, okay, or a swimmer in downstream is 11 km per hour. Means speed of the swimmer plus speed of the water is equal to 11 km per hour, because downstream we have to add. Next, speed of the stream they have given, speed of the stream or the speed of the water is 1.5. So speed of the swimmer plus 1.5 is equal to 11. Therefore, speed of the swimmer is equal to 11 minus 1.5, that is 9.5 kilometers per hour. Very simple, 9.5 kilometers per hour. Option B is the right answer. Let's go to the next problem, problem number 24. This type of problem you can expect in your exam. A boat running upstream covers a distance of 10 kilometers in 30 minutes. While running downstream, it covers the same distance in 25 minutes. What is the speed of the river current? Means speed of the stream in kilometer per hour. See here, speed of the boat plus speed of the water is equal to distance traveled by time taken in downstream. Okay, that is in downstream. Next, upstream, speed of the boat minus speed of the water is equal to distance traveled by time taken. So now upstream I am taking, upstream is equal to speed of the boat minus speed of the water is equal to 10 kilometers by 30 minutes. 10 kilometers by 30 minutes. See, the time is in minutes, we have to convert into hours. So 30 minutes is nothing but 30 by 60 hours, that is 1 by 2. So 2 is going to be in the numerator. So speed of the boat minus speed of the water is equal to 10 into 2, that is 20 kilometers. That is 20. Okay, so now downstream is equal to speed of the boat plus speed of the water is equal to 10 kilometers in 25 minutes only. So if you convert this one into hours, then it will become 60. So 5 5s are 25, 5 12s are 60, 5 2s are 10. Therefore, 12 into 2, speed of the boat plus speed of the water is equal to 12 into 2, that is 24. That is 24. So now we got two equations. The equation 1, speed of the boat minus speed of the water. Equation 2, speed of the boat plus speed of the water. Now see here, speed of the boat plus speed of the water is equal to 24. Next, speed of the boat minus speed of the water is equal to 20. What we have to do? We have to calculate the speed of the water. Means speed of the boat has to be subtracted. So if you subtract, then it is going to become plus, it is going to become minus. See here, what is the speed of the river current in kilometer per hour? So you have to calculate the speed of the water. So after simplification, 2 speed of the water is equal to 4. Therefore, speed of the water is equal to 2 kilometer per hour. So very simple, speed of the water is 2 km per hour. So option C is the right answer. So based on the data what they have given, I have constructed the two equations. With the help of the two equations I have solved, I got C 2 as the answer. Okay, let's move on to the next problem, problem number 25. A boatman rows 1 kilometer in 5 minutes along the stream, means with the stream, and 6 kilometer in 1 hour against the stream. The speed of the stream is very similar to the previous one. See here, speed of the boatman plus speed of the water is equal to 1 kilometer in 5 minutes. So if you convert that into hour, it will be 5 by 60. 5 12s are 60, therefore speed of the man plus speed of the water is equal to 12. Next, speed of the man minus speed of the water is equal to 6 kilometers in 1 hour, which is equal to 6. So see here, now I have to calculate the speed of the water or the speed of the stream. So you subtract both the two. So minus, so 6 by 1, which is equal to 6. So now speed of the man get cancels. So 2 speed is equal to 6. Therefore, speed of the water is equal to 6 by 2, which is equal to 3 km per hour. So this type of questions you can expect in your exam. So option A is the right answer. Very simple problem. Okay, so let's move on to the next problem, problem number 26. Speed of motorboat in still water is 45 km per hour. If the motorboat travels 80 km along the stream in 1 hour 20 minutes, then the time taken by it to cover the same distance against the stream will be. See here, they have given the speed of the motorboat. Only thing is you have to calculate the stream of the water. So speed of the motorboat plus, see, travels 80 km along the stream. So speed of the water is equal to 80 kilometers divided by, see here, 1 hour 20 minutes. If you convert it into hours, see, 60 plus 20, that is equal to 80 minutes. So 80 by 60 hours, that is equal to 4 by 3. So that is 4 by 3. So speed of the motorboat 45 plus speed of the water is equal to 80 into 3 by 4. So 4 2s are 8, 20 into 3 60. So 45 plus speed of the water is equal to 60. Therefore speed of the water is 15. So speed of the water is 15 km per hour. Now the motorboat has to travel against the stream. Against the stream means speed of the motorboat minus speed of the stream has to be traveled in 80 kilometers. So with the time we have to calculate. So see here, speed of the motorboat 45 minus speed of the water, that is 15, is equal to 80 by time taken. So 30 is equal to 80 by time taken. So 0 0 cancels. T is equal to 8 by 3. So therefore, see here, 3 2s are 6. 2 hours, see, 45 minutes or 50 minutes. See, 3 2s are 6, remaining is 2, 2 by 3. So 2 by 3 of 60. So 3 2s are 6, 20, 20 into 2, 40. Therefore, 2 hours 40 minutes. 2 hours 40 minutes. So option C is the right answer. See here, only the thing is you have to calculate the stream of the water. So based on the stream of the water, you can calculate the the time taken by the boat to reach 80 kilometers against the stream. So after calculation, we got 2 2 by 3. So 2 hours 2 by third of the hour. So 2 by third of the hour means 2 by third of 60, which is equal to 40 minutes. So 2 hours 40 minutes. Option C is the right answer. So till now we have completed 26 set of problems, including the problems related to trains as well as the problems related to boats and streams. So if you practice these type of problems, then it is more than enough for you people to clear the clerical exam as well as the PO exam. Please practice the set of problems whatever we have included in our website. Take the topic wise test, that is the subject wise mock test. Take the whole mock test. Okay, practice lot of problems, go with the worked examples, use our discussion forum. If you get any doubts, please post the problems in the discussion forum, discuss with the students. If no one is going to answer means I am there to answer, so that ultimately you are going to get the answer for your question. Not to worry anything, only the thing is you have to practice practice, practice. If you practice, you can solve any type of problems related to this topic. See here, in this topic, only the concept which helped us is the relative speed. Other than that, each and everything is direct questions. Only the thing is you have to use the formulas, you have to implement the values according to the notations in the formulas, you are going to get the answer. And one more thing always you have to remember, that is the conversion, unit conversion. Whenever it is required, you have to convert. In this module especially, so many problems are related to the conversion of units. Okay, so please remember that one and practice a lot. Thank you.